Welcome. Today's algorithm is save the prisoner. A jail has a number of prisoners and a number of treats to pass out to them. Their jailer decides the fairest way to divide the treats is to seat the prisoners around a circle table in sequentially numbered chairs. A chair number will be drawn from a hat. Beginning with the prisoner in that chair, one candy will be handed to each prisoner sequentially around the table until all have been distributed. The jailer is playing a little joke though. The last piece of candy looks like all the others, but it tastes awful. Determine the chair number occupied by the prisoner who will receive that candy. Okay, so we have basically a number of prisoners, numbers of cookies, and we will randomly start and then go around. I see. For example, there are 4 prisoners and 6 pieces of candy. The prisoners arrange themselves in seats number 1 to 4. Let's suppose 2 is drawn from the hat. Prisoners receive candy at position 2, 3, 4, and then 1, 2, 3. The prisoners to be warned sits in chair number 3. So basically we want to know who gets the last piece of cookie. Complete the save the prisoner print function. Okay, so we have 100 test cases. We have a very high number. How much is that actually? This is 1 billion or 10 billion? Okay. For each test case, print the chair number of the prisoner who received the awful treat on a new line. Damn, okay, I don't think we should do a loop or anything of that nature. I think we can already say like a edge condition when, for example, prisoners minus the chair where we start at is bigger equal number of sweets, then we can return number of sweets minus s plus m. No, chair number should always be smaller. No, it's always smaller than equal n. Okay, so then that means s is always smaller than n, but n could be bigger than m, number of sweets, exactly. But if it's smaller or equal than m, then we know we don't have to like loop over. All right, I think that makes sense. Okay, our starting position would always be, starting position is going to be the number of prisoners minus s. That's the leftover. From there, basically while, let's say, sweets, while m bigger than 0, if leftover of prisoners plus, if that's bigger than m, we could say prisoners. And what we could do is, let's put this one maybe down. So like, okay, let's say sweets. And let's say up here, leftover prisoner. Because it's not prisoners. I also want to say sweets minus s, leftover sweets. Now we have the rest of the sweets, and basically we start off with the full amount of prisoners. And we can say if leftover s is smaller than the whole amount of prisoners, we can say we return leftover s, because that's gonna be the prisoner. Else, if it's bigger, we will have to always subtract from the leftover, correct? We'll always have to subtract from the leftover sweets, while leftover sweets is bigger than n, we want to subtract from it leftover sweets minus n until we have it return leftover s, because that's going to be respectively the prisoner, hopefully. Damn, is mutable, left is var. Wrong answer. Your output 3 and 4. input to, let's see down here, what's the sample? And the first query, the n prisoners and m suites distribution starts at seed number 1. Prisoners in seeds number 1 and 2 get suites. Oh, seed number 1, and I'm subtracting s from prisoner, right? Because then I'm already saying, oh, it's off by 1. How off am I? By 2, right? Okay, let's see here, leftover. Let's think it through once more. Basically, if suites, right, suites is smaller than n, then we can return already n. If the suites plus the position is smaller than n, minus 1, correct? Because then we want to say plus s minus 1. We don't want to subtract the number, the 1 basically, from the prisoner's position. Okay, so let's just try that and see we have our first test result. So we are on the right track. Yes, we are on the right track, I think. Okay, expected output 2 and 3, and my output is 2 and 3. Okay, so that's already correct. Now, we want to actually say this, no? So basically we have, oops, where's my leftover? It's there. Let's put it down here. So let's see, leftover suites, we can just leftover like this, is we want to subtract from the suites the prisoners minus s. We have 10 prisoners, we start at 4. And that means we want to just subtract from the suites the 6 if we have, for example, 15 suites, right? So then we have 9 left, and we know we're starting over with our full amount of prisoners. So then the leftover suites, let's call it loss. As long as loss and starting position is minus 1, because we don't want to count the first starting position. Alrighty, that means we want to say as long as loss is bigger than n, we will subtract from loss the whole amount of prisoners, and then in the end we have a leftover prisoner, leftover suites, which should be the result for the code. Identify p. Whoops, I say p for prisoners when it's actually n. Alrighty. That works. Submit. Damn. Okay, wrong answer. Somewhere, like by a lot. Maybe some edge cases. Let's check them. Unlock. Ah, damn, I cannot really probably work with this. 5 truncated. Truncated the result. The first few results, input, expected output. I don't even see my output right now. Alrighty. Oh, and we want to also catch the, what if it's 0, right? What if loss is equal to 0? Then we want to return 1. Let's just catch that one too, because it could equal to 0, which means it's the first. And wait a second, it's the first or is it the first position? Because we're taking away. I wonder if we always want to say +1 actually, loss +1. Let's think it through if that makes sense. We have leftover suites, 3, and we have 3 prisoners. That means if it's 0, it's the 3rd prisoner. It's the last prisoner. Okay, if loss is equals 0, we want to return the prisoner. If it's not 0, that means, we have 1 or 2 or 3. That's the actual position. Let's see if that actually made it. That's a lot more cases succeeded. Okay, your code did not execute within time limits. That's a different, yeah. So if it's bigger than n, we do something. If it's smaller than n, we say if loss is equal to 0, return n, else return lost. And what we could do is, instead of here all of this, we could say we have the leftover prisoners, which is n, but let's say p maybe, is lost divided modulo n. That's our position. Basically, return that, if I'm not mistaken. Let's try this locally. Damn, it doesn't succeed for this case. Your output is 6 and 0. Expected 6 and 3. We need this leftover prisoner equals that one. We need this check here as well. If leftover, is it prisoners? It's actually leftover sweets. It's just, I don't know, let's call it leftover. If leftover is 0, we want to say n, else we want to say leftover. Now we're succeeding locally and hopefully also remotely without like a huge loop. Yes, great, that's awesome. Okay, thank you very much. I hope you enjoyed this algorithm. I found it not as easy, but still solvable. And if you want to see future algorithms, you can subscribe. I will upload an algorithm per day, and hit a like if you like me solving an algorithm. Also leave a comment if you have anything to share with me. Hopefully see you in the next one. Bye.